Have you ever wondered how we communicate with computers?
Hey, just wondering if you got your photos printed?
I mean, sure, Google. But how does a computer understand us whenever we use our fingers and a keyboard? Or perhaps you have gone into your computer's command prompt only to find an illegible error code of ones and zeros. Well, this video will explain how we communicate to a computer and what exactly those ones and zeros mean. And by the end, you might even be able to understand it a little. First, we start with the basics. What do the ones and zeros stand for? What you are looking at is binary, not that binary, but this binary, a base 2 numerical system consisting of ones and zeros. Each individual character represents a bit. Whenever you see a 0, that bit is off, and whenever you see a 1, that bit is on. These individual bits don't really mean anything to us or the computer, but when presented as a group of 8, it creates a byte. These bytes are how we communicate to a computer, or else all a computer would hear is
What?
Now, before we continue, remember the first modern computer, the ENIAC? That computer was invented in 1945. However, the binary code system was developed way before the ENIAC by this guy, back in 1689. The origin of the word binary comes from the Latin binarios, or consisting of two. Now, let's get back to explaining how we understand binary. First, byte or 8 bits. Let's imagine a rectangle with boxes dividing each bit we have. For now, they are all off, so we will write a 0 in each box. Each of these boxes represents a number, but what numbers do they represent? Well, it's just the number 2 to the power of x. For example, the first box represents 2 to the power of 0, which results in the number 1. The next box is 2 to the power of 1, which gives us 2. 2 to the power of 2 gets us 4, and it continues until we get to 132. But remember, at the moment, all these boxes are still turned off, so our output would still be 0. Now, going from right to left, let's turn on the first box that represents the number 1. By replacing the 0 with the 1, boom, now our output would be 1. To get the number 2 as our output, we would turn off the first box and turn on the second one. Now, we go back to the first box and turn that one back on to get number 3 as our output. Now, turn off all the boxes and turn on the third box to get the number 4. Turn on the first box and we get the number 5. And in a way, we repeat the same pattern to continue going up. Now we can count in binary. Cool. Using a similar process, we can also use the alphabet, although instead of 8 bits, we only use 7, and the leftmost box is always on, in order to avoid confusion between letters and numbers. I would explain it, but it's essentially the same thing, with this representing the letter A, this for B, so on and so forth. Here's a chart for reference on binary code. It's crazy to think that by only using ones and zeros, binary can print out a message like this. Okay, but now what? We can speak to a computer, but having to speak to our computer with the screen looking like this can be overwhelming and confusing. That is where programming languages kick in. Although you could technically code an entire program by only using binary, it would make it very difficult to understand and perhaps impossible to debug. With programming languages, essentially, all you're doing is transforming binary into shortcuts, using words to represent the binary in a more legible way, making it easier for us Binguses. Now, we need the computer to understand us. To do that, we simply reverse the order in which we learned this information. For example, if we open a program and it asks us for our name and age, whenever we type our input and press enter, the program will convert our words into letters, which is then converted to binary, where it is interpreted by the CPU, which processes them very quickly. Another example is a calculator program. If we tell our computer to process 12 plus 57, our computer will not calculate them as 12 and 57, but instead as 00001100 plus 001110001 to give us 01000101. If you watched our last video over computers, you would know that the step-by-step process would go from our keyboard through the USB into the motherboard, then to the RAM, until the CPU processes it and stores it into the hard drive. And that's really all I can explain for now, because like you guys, I'm also learning along the way how technology works. And if you think about how complicated all of this might seem, remember, a computer didn't come up with any of this. A human Bingus had to program all of this. Computers aren't smart, but the Binguses that created them are. Thank you for watching. This has been Bingus. Don't forget to subscribe and like this video for more content like this. Thank you very much. Bingus.